Hi everybody, and welcome to another part of the Solidity tutorials. In this part we're going to continue with the voting contract, and in this part we're going to make it much more complex and customize it in a way that only certain candidates can be voted, and if the candidate is not in the list or has not registered, then there's no way you can vote anybody else. Also, we will write a function using which the candidates can register for voting. So we will use this contract that we have written on the simple vote.sol. So I'm going to copy this and create a new file here in the contracts folder. New file complex underline vote.sol. Enter and paste it right over here. Now I'm going to add another kind of entry point or a variable here, a string. So this is a kind of an array containing the strings related to the candidates. So public candidates, there we go. And here we'll first define a function. The name is register candidate. And here we'll get the candidate a string memory candidate. So candidate actually. So public, and also make sure you write in the correct way, candidate. Okay, and now public function, which we're going to use, and then open the bracket. So here we need kind of a require statement here. So here in the require, we'll check whether the candidate has already registered or not. So if the condition holds, meaning that if the is not the candidate, we'll continue. Otherwise, we'll show this to the user: candidate already registered, candidate already registered. There we go. And if that condition holds, then we will push the candidate.push to the array of the candidates. So candidates.push, and then we'll have the candidate. There we go. So now it's time to go after another function, which is voting. So we've written that voting function, and afterward we will need another function. So here we'll check whether the vote is the candidate or not. So we'll define a function is candidate, and here we'll have, so actually in the above we had is candidate, which is going to use the is candidate function right over here. So as the input we will have the string memory candidate, and then internal view returns. This is about the output. So in some of our functions we will have internal view returns, and this is related to our output. Because we're using this function in another function, here we'll have the internal, which means that it is going to be used internally instead of our contract, not in another contract. So internal view means that it's going to output something. Returns and then we'll have the type boolean, bool, and then we'll have the brackets. So we'll have a for loop here, and for that we can write for u in 256 I equals to 0. So this is like JavaScript for loop, so I is smaller than candidates.length, and then I++. There we go. So we'll loop through the candidates array and see if there is any if the candidates is repeated. So here in the most of the programming languages, actually nearly all of them, we will just check the strings and the characters. But here we will hash the candidates, and this way we can make sure everything is secured, and also we can check everything in the right way. So I will explain how we will hash the candidates. So here we will have the if statement, and so open the parentheses, and we'll have the catch 256 for hashing. It's written this way, 256, and then we'll have bytes, and then we'll have the candidates, I, and so what we'll do here is we'll check whether the candidate exists in the array of candidates. So catch again, catch 256 bytes, and then here we'll have the candidate. Okay, and now if this condition holds, meaning that if the candidate here, the hashed candidate, is in the list of the candidates, is in the array of the candidates, then here we'll return true, and otherwise it will return false. So return false. There we go. Don't forget semicolon here, and there it is. So that's it for the contract. Now let's save this and see if it gets compiled. There seems to be some errors right over here. Is candidate function, so it's not about the spelling here, but I've just fixed it. So let's see what is the error. So string memory, so it's about the candidate. Okay, here is string memory, this is the type, and here we'll have string memory as a type. Okay, so here when we called this function, we haven't entered the candidate variable. So the candidate is input of this function, so also the input of this function, so we will need to enter the input. Here we had forgot it, so let's now save this. No error, and it has been compiled successfully. Now we can deploy it here, so we don't need to delete this, but I'm going to do that. So we have complex vote to be deployed. It's been deployed successfully. Now let's check everything. So register the candidate. Here you can enter a string type. For example, here I can enter Sally, and then register the candidate. I can also register for Brian, also register for this candidate. So now we have two candidates, Brian and Sally. If I enter Sally again, let's see what happens. as you can see, we received the error. A candidate already exists, already registered. So now we can vote for either one of the candidates, for example, Sally. And now we can vote for Sally. You can skip the candidates, and here we can check whether this address has voted. So I'm going to copy the address, paste it right over here just as before, and as you can see, it's true. We have voted with this address. Now let's check the Sally vote count. As you can see, it's 1. Now let's check this for Brian, and check the vote count, it's 0. Now we can register other candidates too. For example, here I can enter Emily and register the candidate. So now let's check the address to this one and vote for Brian. Vote and check the vote count of Brian. As you can see, it's now 1. And check whether this address has voted. And as you can see, it's true. So that's it for this contract. We've successfully tested everything, and everything is written correctly. So that's it for voting. In the last part we had a simpler kind of voting contract, and in this part we've made it a bit more customized and more complex. And also notice that we've become familiar with the for statement, if statement, and also in the last part we got familiar with mapping. In this part we got familiar with the Keccak 256. And you might wonder what Keccak 256 is and what kind of function is it, why do we use it. So in general Keccak 256 is a hashing function used to compute the cryptographic hash of a given input. It is based on Keccak 256 algorithm, which produces a 256-bit or 32-byte hash value. So in Solidity, the Keccak 256 function is used for various purposes, such as generating unique identifiers, verifying data integrity, or comparing inputs. It takes an arbitrary length input and returns its corresponding hash value. So in the context of voting contract, Keccak 256 here is used to compute the hash of each candidate's name. By comparing the hashes, the contract can check if a given candidate is already registered or not. So we use it for comparing the candidates, and here using this method, it's more secure, and it's a much better way when you want to compare, and so it is much more recommended than other way of comparing. So also notice that in the recent versions of Solidity we also use type uint 256.max. So it's written this way. We will use it in the future tutorials. So if you, for any reason, if you get any error from this one, or if it's somehow complicated, you can use type uint 256.max like this, and it's going to be instead of the Keccak 256. So I hope you've enjoyed this tutorial, and until the next one, goodbye.